All right. Thanks to everybody for joining. I really appreciate it. I'm going to give a quick power talk on Energy.X and what we're doing to impact the renewable energy transition. So, thanks everybody for joining. Quick disclaimer, we do have some forward-looking statements in this. So I'm basically going to cover a few things. First, a little summary overview of what we do, then dive a little bit deeper into the technology, and finish up with some business highlights. So what is Energy.X? Energy.X is a company that is working on two key initiatives, both that have to do with energy storage systems and the transition to a sustainable energy future. The first initiative that we spend about 90% of our time on has to do with direct lithium extraction. And it's somewhat far up the supply chain, but we're actually working on how lithium, which is one of the most important battery materials, is actually produced. And we've developed a method that I'll explain in further detail that can increase the recovery rates by up to 300%. A lot of people compare this with the efficiency addition of what fracking is to, say, the oil and gas industry. However, fracking is looked at as a dirty practice. We actually improve the sustainability of the mining practice with our technology. The second is technology that enables solid state battery electrolytes. And that actually stems from the same core technology that we use for lithium extraction. Both are membrane based technologies. So that's kind of the high level overview of what we're working on. And I founded this company in 2018. I've been working on it 18 hours a day for the past 3 years. So a quick high level by the numbers. Thus far, there's been about 4 million invested, a million of which I personally invested in the company to get it off the ground. Since we've actually closed our Series A raise of an additional amount of capital that has not been announced yet, that'll come out probably the same time as this podcast or this Power Talk. We look at ourselves as an energy technology company. We're very asset light. And what that means is we put a lot of focus and attention onto our patent portfolio. To date, we have 23 patents under our control, and we look to build upon that patent portfolio. Our goal is to get that into the hundreds by year end or sometime in 2022. We have a team of about 15 team members, and that's growing. This year, with the additional capital raised, we're going to triple the team size, probably up to 50. And those will all be housed in a new 15,000 square foot lab that we're building in Austin. As far as the operations of the company, we're deploying 3 pilot plants this year over the summer with some of the top lithium producers in the industry. I'll get a little bit more into that. So enabling a greener future, what does this mean for the lithium market? Well, the first thing is demand. And we all know that the renewable energy transition is predominantly driven by electric vehicles. And those electric vehicles need big batteries, which batteries mean a lot of lithium. But it was surprising to even me how big that supply-demand imbalance actually is. Today, or last year, we produced about 300,000 tons of lithium. By 2025, that number is going to be 1.2 million, maybe more. That's a 400% increase. And by 2040, that number is predicted to be at 5.5 million tons of lithium per year. So that's the first key point, is the demand. The second is our approach. And this is really what differentiates us from the other direct lithium extraction companies that are out there. You know, I'm not the first person to realize that there's a huge problem with this supply demand imbalance, and other people are trying to tackle this issue. However, our approach is to work with the existing infrastructure. Now, whereas other direct lithium extraction companies are looking to replace this pond infrastructure that you see up here in the top left picture, that's not something that the major producers that run these operations want to do. That would be a huge write-off on their balance sheet, and they're already working right now. So what our approach is to come in and complement that approach and make it much more efficient, which is point number three. So we've developed this system, a membrane-based mechanical separation technique that increases recovery rates from roughly 30% lithium recovery all the way up to 90%. That's 3x conventional methods. This substantially decreases OPEX on cost per ton. And leading into point four, what that means is substantial economic returns for our customers. And if you know big projects, uh, these companies look to make, low teens percent in IRR. With our complementary technology, this is 30 plus percent IRR, which is absolutely astonishing. So a quick chart, just to touch on that demand supply gap a little bit more. I like this because it shows both the internal combustion vehicle versus battery electric vehicle line, and then where lithium fits into that over a certain time period. And as we move past kind of 2027, there's this huge spike in demand because of the number of cars that will be developed and the manufacturing lines that are coming on for all the rest of the auto OEMs other than Tesla. And that's where you start to see a huge, huge gap. Now, making money is obviously important, but we look at this as something that's of the greater good. And when I decided where I wanted to focus my time and energy on a business, I decided that it needed to have some sort of environmental impact. That was really important to me. So, this is an impact investment, and we focus a lot on ESG and sustainability. And I did some quick numbers here that you can look at. For every ton of lithium produced, that eliminates 135,000 tons of CO2 when it's utilized in passenger vehicles, and 55,000 tons. And you can add those together. So if you produce energy from solar or wind and then use that in your vehicle, you can add these numbers together, and that's the total reduction. Now, what that means to get to half a gigaton of CO2 reduction is only 3,720 tons of lithium utilized in electric vehicles. So what's the technology? We've developed this lithium refinery technology based on a new class of materials called metal organic frameworks, which I'll show you on the next slide. But I just want to talk about a quick comparison chart here in the time it conventionally takes to produce lithium through evaporation ponds versus our direct separation technology. The recovery rate, I already touched on that. Another aspect of sustainability, I mentioned that as fracking is kind of a dirty process, we have a much more clean process than a conventional process. Now, that has to do with two things predominantly. One is footprint. These ponds that I showed you on a few slides ago are 15 square miles. That's the size of Manhattan. Our facility is 1 square kilometer, very small. But the other key here is fresh water used. And fresh water is very scarce in some of these regions where lithium is produced. And it can disturb the existing waterbed for surrounding not only natural ecosystems and animal life, but also indigenous people that live around these facilities. So we use about 800 gallons per ton of lithium produced as compared to about 18,000 gallons per ton. What this leads to ultimately is cost comparison and OPEX for producing per ton of lithium, which we significantly decrease. So what is MOF technology? Metal organic frameworks, like I said, are a new class of materials that are metal nodes connected by organic linkers. And what that means is they have adjustable pore sizes that can allow lithium to pass through an atom of lithium while rejecting the other salts that are typically found in these brines, i.e., magnesium, calcium, uh, sulfate, potassium, sodium. The idea is you have these brines that are about 30% salinity, so 70% H2O, 30% salts that are all mixed up and saturated in the brine. And lithium makes up a very small percentage of that, but it's a relatively large percent compared to where lithium is found anywhere else. And you need to separate lithium from all those other impurities. And that's what these moths do. Lithium is allowed to pass through the pore, and the other ions or salts are either too large or rejected because of electrochemical affinity. So what we did was we put these moths into a mixed matrix membrane. So we had polymer adhesive, which kind of acts as a glue, combine all of these moths evenly distributed in a percolation network. These membranes are able to operate at the high salinities that the brine contains. It's a continuous process. The brine continuously passes through the membrane, letting the lithium go through and rejecting the others in a cross-flow mechanism. We use minimal fresh water, and we have low power consumption. And for all those reasons, we've developed a winning technology. So what does the current production process look like? Now, you saw those ponds, but this is kind of a schematic broken down. The ponds break out into 4 separate ponds where it's pumped from the well into the first pond, and you have about 0.17% lithium. A lot of H2O is evaporated. It sits in that pond for 4 months, and sodium is precipitated. Then it goes to the next pond. You can see the lithium is concentrated up a little bit more, and potassium is precipitated. Lithium is concentrated up a bit more, and magnesium is precipitated. However, you need to get to 6% lithium in order to crystallize it into the salts, the lithium salts, that are used in battery grade material. And when you go from this magnesium precipitation at 1.5% up to 6, that's when lithium starts to co-precipitate with magnesium. And that's where you see about 50% of the lithium loss. And that is just a huge, huge amount of loss. And over this whole span of 4 ponds, it takes about 18 months to cycle through. So what's our solution? Instead of replacing all the ponds, like I mentioned, with other technologies that companies are developing, we complement and we fit in right between the 3rd and 4th pond. Now, what this does is a few things. It eliminates the lithium magnesium co-precipitation, so we have a concentrated, purified lithium stream coming out. But also importantly, we're now able to treat a significantly less amount of the brine as opposed to the initial well. So out of the initial well, you could have millions of metric tons of brine coming out, but through the first 3 ponds, a tremendous amount of water is evaporated and other unwanted salts are precipitated. It's actually a very efficient process. However, when it gets to here, we're at about 100,000 tons of brine. So we treat 1/20th the amount of brine, which equates to substantially lower capex because we have far less membrane surface area. And this is a much quicker go to market because we're working with the biggest customers and the biggest producers as opposed to trying to replace what they're doing. I like this chart because it kind of visually shows the drop off that occurs in the 3rd pond. So in the 3rd pond here, you can see when you go from about 1.5% lithium, and this is calculated in ppms, which is parts per million, up to, call it 5.5%, you lose from 90 down to 30% of the lithium. But with us, you just maintain that because all the lithium is passing through our membrane and all of the unwanted salts are being rejected. And now you're at a high concentration with a purified stream. Now we do have even further generations. We recognize that ultimately nobody wants to build more ponds, right? And the goal is eventually to eliminate the ponds, but that's That's too big of a transformation and too big of a risk for the existing producers. However, eventually, when the ponds are completely maximized using our generation one, we have developed an end-to-end solution that can be generation two and replace the ponds. This is a super small footprint. It is minimal freshwater use, again, same recovery rate, and slightly higher IRR return for the customers. Even further than that, we're developing a generation three. And this again optimizes the supply chain in delivering the lithium. Now, on the last slide, you might have noticed that after the brine comes into the final processing plant, it needs to go through a step called lithium carbonate, which is a battery grade material. However, all the big auto OEMs want to use lithium hydroxide. It lasts longer, and you don't want a car that the battery dies after 2 years. You want your car to last 10, 15 years, and that's why you need lithium hydroxide. So currently, the only way to get to lithium hydroxide is by going through lithium carbonate that was shown on the last slide. We're developing a mechanism that can cut out lithium carbonate processing and go straight to lithium hydroxide. The numbers on this are less than a year return for customers. We have $5,000 per ton of CapEx savings and $2,500 per ton on OpEx. The numbers are investment payback in less than a year. So the competitive analysis. EnergyX is pretty much the only company that is using membranes as the solution to improve lithium production. The other big ones are using ion exchange and ion desorption. And as I mentioned, they like to go from the feed, and that's why they're not complementary, which turns out is the biggest stickler for the producers. However, they do have other drawbacks. Now, while they are efficient in the separations that need to occur, they're over here in the two left columns, they're not a continuous process. The lithium absorbs up into a sponge, and then you have to leach the lithium out using chemicals, so it's non-regenerative. And then finally, you have to wash the system with a lot of fresh water right here on the right before you use it again. So for all those reasons, we again believe that we have developed a winning technology. So now I'm going to get a little bit into the business highlights. Our intellectual property is one of our keys, and we've developed 23 patents over 9 patent families. And again, we'll look to continue to expand that. Our business model. So this is important. We look at ourselves as an asset-light company where we partner with the world-leading manufacturers and we partner with the resource owners. What that means for us is that we will receive a technology fee for every ton of lithium produced using our technology. Also, on the sale of equipment, we'll take a small profit share for the actual membrane that's produced. Around the membrane is a lot of ancillary equipment to build out the balance of plant, and our manufacturing partners will make all the margin on that. Some of our key customers, we're working with several of the largest lithium producers in the world, testing their brine. And again, I said that we are looking to deploy pilot plants in the field, 3 of them, with a few of our select customers. Some of our partners. So the original IP was licensed on a worldwide exclusive basis from the University of Texas. They're partnered with the Australian National Laboratory System, CSIRO, on that. We also have technology licensed from Prof. Moth, which is a spin out of the University of Oslo. And the US Department of Energy put substantial funding and grant money into Texas to develop this core technology. It's something that's been worked on for thousands of hours with millions of dollars of backing to get to this point. On the commercialization side, we partnered with a firm out of the Bay Area called MTR, which is renowned for scaling novel membranes to the pilot level. And then on the commercialization side for large manufacturing quantity, we've partnered with Suez, who's a world leader in water technologies and membrane manufacturing. So where we are today, we've completed our membrane scale up at MTR, and we're in the pilot plant phase. We have 3 working pilot plants in our laboratory, And during summer, we will containerize those in full standalone shipping containers that are self-reliable in terms of power, water, etc., and ship those into the field for 6 to 12 month testing. After that, we will look towards commercialization. And the key here is that all of our systems are prefab and modular. So as these customers look to expand their production, it's just a matter of us sending down more stacks of our technology to add to what they already have. So what do our pilots look like? They're containerized systems, as I mentioned. We'll have multiple on site this summer that will be testing in real field conditions for 6 to 12 months. And our completion goal is to have all of these in the field over summer, but max by the end of 2021. Quickly on our team, I'm Teague. It's been a pleasure talking with you. Our CFO, Bob Woke, is very experienced, comes from Linde, which is a large gas separations technology. Amit Pat Warden spent 12 years at Rio Tinto, the second largest mining company in the world. And we have several directors of different aspects of our technology, including Rochelle Linden, who did her PhD at Georgia Tech and is an expert in moth chemistry. On the advisory side, Benny Freeman is our closest advisor and the chairman of our science advisory board. He's actually the professor at University of Texas that invented the core technology. And what's really special is that Benny also personally invested in the company, which is somewhat of a rarity for inventors to do. Bob Galen is the former CTO of CATL, the largest battery manufacturer in the entire world. My dad, of course, I spent 20 years at the dinner table with him. He's the former CEO of Alamo Rent-A-Car, as well as several other successful exits across food and beverage, internet technology, and travel. And Rob Morgan, the former CEO of GE Energy Storage, has been a guiding light for the past year. So key takeaways, IP, we talked about that. Partners, we have some of the best partners in the world. Lab, currently we're at 1,000 square feet out of MTR, but building our 15,000 square foot lab in Texas. We have about 15 team members. We're engaged with all the tier one level lithium producers. We've done third-party economic validation with one of the top firms, Benchmark Mineral Intelligence. We're deploying pilots this year. We closed our Series A funding and are leading into our Series B in June or July. And we have a 3-year research agreement with Texas and a 2-year research agreement with Prof. Moth. And that is it, gentlemen and ladies. I thank you very much for your time.